Hello guys. So today I want to cover scale factors and basically how to do the similar shapes homework that I gave you this week. So what I want you to understand first is what a scale factor is. So a scale factor is in this case represented as k. It just tells us how many times bigger one shape is compared to another. So for example, if we were told that this shape A and B, that B is twice the size of A, the scale factor in this case will be 2. So what about if we were told that it was even bigger and that B happens to have a length of this equals to 12, whereas A has a length of this equals to 3. So how will you calculate that scale factor? Well, the scale factor is easily calculated by just taking the largest length, in this case length, remember, and dividing that by the smallest one. In this case, our answer happens to be 4. So what I want you to understand is that first, whenever you are determining a scale factor, always make sure that you take length, so you take measurements, so you're using values that represent the same thing. And by that, what I mean is that you have to make sure that you take a value that represents this hypotenuse, so this line, and for the other one, you also have to take exactly the same length, because you cannot compare this length to this one. Why? Because you will be comparing the hypotenuse against something else. So the hypotenuse will be compared to something like the objective or the adjacent or this vertical line, which is something that we don't want. So just to reiterate, we want to compare values that are representing the same length and the same measurement of an object. Okay? So in this case, just reiterating, our answer happens to be 4. What that tells us is that for that length in specific, B has a measurement or has a length 4 times bigger than that of A. Okay? So if I wanted to do exactly the same thing for the example I got here, up here, so I'm gonna just cross it. What I got here is that A has a length of 2 and B has a length of 1, and therefore our scale factor is equals to 2. So if we use another example, like the one that I got here, so we have A and B again. So if we wanted to compare what the scale factor is here, again, the scale factor is equals to the biggest measurement by the smallest, or the smaller one. In this case, our scale factor happens to be 6 over 2, which is equals to 3. So B is 3 times bigger than A, which makes sense in this case. So again, all of these examples I've covered represent lengths, or are used the length of an object or a shape to determine the scale factor. Therefore, the scale factor that we are calculating here represents a one-dimensional object or measurement. So just have that in mind, okay? So that scale factor, I'm gonna add a little one here, 1D, just for you to understand, represents a 1D scale factor. Okay, so what about if we have area? So why area is in this case? The reason is because area does no longer represent a one-dimensional measurement. It represents a 2D measurement. Okay, so in this case, if we wanted to compare how many times the area of B is bigger to compare to the area of A, we could not do exactly the same thing as we have done before. We could not just take the lengths, because those lengths will be representing a one-dimensional measurement, and in this case, the area is not a one-dimensional measurement. Therefore, in order to represent the two-dimensional measurement that area is, we have to calculate the area of A and B, and that can be easily done by just applying the formula of the area of a square, which is 2 lengths multiplied together. So 2 times 2 equals to 4, and for B, the area is equals to 4 times 4 equals to 16. Okay, so our area is equals to 16 for B, and our area is equals to 4 for A. So if we apply exactly the same rule that we have discussed before, or formula, the scale factor, which is K, and again the scale factor tells us how many times B is bigger to A, could be calculated by just taking the biggest number, and remember in this case we are taking the area, because the area is the 2D, or the two-dimensional measurement, 16, and dividing the biggest number by the smaller one, which it happens to be 4. So our answer here ends up being 4. Okay, so our scale factor is equals to 4. Therefore, what that means is that the area of B is 4 times bigger than the area of A. Okay, so if we were to put that in a mathematical formula, the area of B is equals to 4, which is a scale factor. I want to write it down here, multiplying the area of the smaller object, which happens to also be 4. So area so as you can see, I want to move this here just for you to see this is slightly better. 16. So what we got here is just a nice mathematical expression showing how the scale factor is related. So again, the area of B is equals to the area of A multiplying the scale factor. Why? Because the area of B is 4 times bigger than the area of A. And in order to obtain the area of B from the area of A, you will have to multiply the area of A by K, or the scale factor that you have calculated. I don't know if that made sense, because I know that I'm repeating a lot of words, but I just need to make sure that I'm emphasizing what I'm saying. So yes, please, if you don't get something, just drop me a message and I will explain it quickly. So knowing now that you can calculate, or you should be able to calculate, what a scale factor is, I would like to get into the questions. So the way how you do these questions is just literally by calculating scale factors. So in this case, because all the measurements in question 2 that we got are lengths, because all of them are lengths, and these two shapes are mathematically identical or similar, and both shapes have all the same angles. And all the same angles in both shapes happen to be the same. All of these angles happen to be the same for all the shapes, for both shapes. So you should be able now to just take a set of lengths, and this one in this case, and remember the lengths that you pick have to be from the same place in the shape. So it has to be from this bottom length and this bottom length, if you were to take any of those two. So both of them have to be from the same point in the shape. And then once you got the lengths that you want to use, you just calculate the scale factor. And again, we've said that the scale factor is equal to 9, or the highest, divided by the smallest, which happens to be 6. And in this case, if you put that in your calculator, you get 1.5. So what this number tells us is that any length, it might be this one compared to this one compared to this one, or this one compared to this one, is 1.5 times bigger in this one compared to the one that you got here. Okay, so what that means is that in this example, which is asking us to calculate the length of LP, which is this one, LP, which is the bigger one, should be equals to, I'm gonna call it actually x because it might be easier. I'm gonna call it x. X should be equals to the scale factor, okay, multiplying the smaller length, which happens to be 5. Okay, so in this case, if we put the value that we got for the scale factor, x is equals to 1.5 times 5, which is 7.5. So our answer is 7.5 in this case. Okay. Again, the way how we got this is just by, again, calculating the scale factor for one set of lengths that represent the same position or they represent the same measurement in a way in the shape. And by measurement, I mean position. Literally, I'm taking this line and comparing it to the line that is identical in the bigger one. And by comparing that, I'm getting the scale factor. And once I get the scale factor, I can just use the mathematical expression that I've written down here, which is basically telling me that x is equals to 5 multiplying the scale factor we got, or that x is equals to 1.5 times the size of the smaller one. After I do that, I get 7.5, which is the answer for our question.